Welcome to one session of discussion of JEE main paper, chemistry part, shift 1. This question paper is also of moderate type, not so easy. There are a few questions which are easy, but even then, there are questions which require thorough knowledge of chemistry part, but not a difficult question. If you have studied the fundamental principles given in NCERT textbook, of course, you have to apply it, not direct question. You can answer this paper, and that is what is expected of JEE. Yes. Now you go to question number 1. It's a question from environmental chemistry, pollution part. The incorrect statement among A to D regarding acid rain. Actually, they have changed to in cannot. That is what is wrong. Actually, all these are effects produced by acid rain. Acid rain will corrode water pipes, correct. It will damage structure made up of a stone, correct, especially marble stone. It cannot cause respiratory ailment is wrong. It can actually cause respiratory ailment because acid rain will contain the oxide of nitrogen and sometimes oxide of sulfur, but chance is for oxide of nitrogen. So that way it is acidic and respiratory problem may be there, and also it is not harmful is wrong. It is definitely harmful for tree. Yes. So that way the answer will be C and D. What you require is the incorrect statement. So C and D will be the answer, a direct question. Now to question number 2. 3 isomers ABC of molecular formula C8H11N give the following results. A question from second year organic chemistry. Nitrogen amine chapter, actually amine, and there are reactions given. The compound given in sequence is this is A, second is B, and the third is C. And the property given by A and C given. Both A and C can undergo diazotization. It can undergo diazotization mean it is actually a property of a aromatic amine, aniline or the derivative. So there should be a amino group attached to the benzene ring. So this can be the answer, this can be the answer, this also can be the answer, last one also possible. Similarly, last one also contain, they are all derivatives of aniline, so that also is correct. But there is something given regarding B. B is a compound that reacts with benzene disulfonyl chloride, which is also called Hinsberg reagent. And Hinsberg reagent reaction is characteristic of primary amine, secondary amine, and tertiary amine. And in the case of secondary amine, you are getting a product which is insoluble in alkali. The test is amine treated with Hinsberg reagent. If you are getting a product that is soluble in alkali, primary amine. Insoluble in alkali means secondary amine. So B should be a secondary amine. That is right. This is secondary amine. This is also secondary amine. This is secondary amine, but the last one is primary amine. So one thing about this is 4 cannot be the answer. Now out of A, B, C, 1, 2, and 3, which can be the answer. Go to the next step. After diazotization, you are getting 2 products P and Q, but they are subjected to hydrolysis. You know, a diazonium salt, hydrolysis of a diazonium salt will give, this is, for example, aniline. Let us take it aniline. Diazonium chloride will be N2 plus Cl minus. On hydrolysis, that will become phenol. This will be completely replaced by OH group. You are getting a phenolic compound. NH2 replaced by phenol. So if so, after hydrolysis, this will become, NH2 become OH. So it is meta-ethyl phenol. This will be phenol. That way, these 2 compounds become phenol. First one will be, if this is the answer, one will be, you are getting a product with the structure phenolic group at this position, and this will be CH2CS3. This is the compound obtained from this one. And the last compound will be, here OH will be ortho with respect to the substituent CH2CS3. So in this case, the product will be, OH will be, here it will be OH at the position here, and this will be the CH2CS3. So effectively, you are getting one product which is, oh, is it ortho? It should be ortho. Yes, it will be CH2CS3. Okay, and this compound ortho, and this is meta. But next is, there is another step given, oxidation by alkaline KMnO4, a typical reaction of a toluene type compound, benzylic compound. They will undergo side chain oxidation giving carboxylic acid group. So the next step will be, these ethyl groups are replaced by COOH. Reaction is well known and known as, actually it is side chain oxidation. So this compound should be COOH, and this phenol part is already there. And this compound will be a similar compound, but COOH will be adjacent to this OH. So are getting these two compounds. So after the completion of this step, one product will be either this or this. One will be marked, what is that given? One will be marked R and the other will be S. But we don't know which is R and which is S. One of them is R and the other should be S. Now how to distinguish? There is something given like R has lower boiling point than S. So compare these two, which will have higher boiling point. Boiling point is affected by association. In this case, we have got intramolecular hydrogen bonding. OH and COH being very side by side, very close to each other, intramolecular hydrogen bonding. But in this case, they are far away and it will have intermolecular hydrogen bonding. So there is association due to intermolecular hydrogen bonding in this case. So naturally, they should have higher boiling point. So which will be having higher boiling point? What is given is R has lower boiling point. Lower boiling one is this one. So this should be R and this should be S. This should be R, means this should be R. And that way, if you look at it, the possible answer will be only 3. See then, ortho. And this will be, so the given compound, if that condition is satisfied, boiling point should be lower. The only possibility will be 3. That way it will be. See, 4 cannot be the answer, because this is a primary mean and that does not agree with this condition. So leave 4. Out of 1, 2, 3, this is the only possibility. Here it is, here and here will be para. So when there is intramolecular hydrogen bonding, there is a possibility for intramolecular hydrogen bonding mean higher boiling point. And what is given is R has got higher boiling point mean, that will be the indication. So in this case, the possible answer will be this one. This product should be R. This product is obtained from here. And this will be the first one mean, this is the possibility. Okay. Now you have, this cannot be the answer, you can verify by the same method. Okay. Now you have next question, number 3. 5 successive ionization enthalpies are given. Very simple question from periodic classification, or you can consider this atomic structure also. Valence shell control. 1, 2 and 3, 800, 2427, 3658. Normal increase in ionization energy indicates successive removal of valence electron. But the next electron cannot be removed easily. It requires 25,000 etc. energy, kilojoule. That means there are only 3 valence electrons. First one removed by supplying 2427 energy. Second one requires slightly excess energy, expected 3658. And the last one, 800, 2427, 3658. But a sudden jump from 3658 to 25,000 mean electron has to be removed from inner shell. So the possibility will be there are 3 valence electron, answer 3. Next question 4. Consider the following reaction. It's a not a difficult question, but not easy also, because you know there is a reaction mentioned there which is not so familiar, as such it is not given in NCERT. What is that? A compound containing several types of OH. This one is phenolic OH. This is a secondary alcohol group, and this is a tertiary alcohol group, and here is a primary alcohol group. So this compound contains primary alcohol group, secondary alcohol group, tertiary, and phenol. And that compound is now treated with chromic anhydride. Chromic anhydride means chromic acid, CrO3. Oxidation is possible for order. Primary oxidation possible, secondary also can be oxidized. Primary to aldehyde, secondary to ketone. But chromic oxide does not oxidize tertiary. But phenol also, a similar oxidation is not possible. Therefore, after treatment with chromic anhydride, this will be converted to ketone. This will be converted to aldehyde, but tertiary remains there. So the OH marked B will remain there. Also OH marked D, that is phenolic. Now this product is giving positive test with steric ammonium nitrate, and that is the test for a alcohol. See, an alcohol, ROH, when treated with steric ammonium nitrate, will give, this reagent is a yellow reagent, and that will give a red color due to complex formation. Red color is characteristic of alcohol. Steric ammonium nitrate, a reagent, can give red color with alcohol. It will be actually given by all types of alcohol, primary, secondary, or tertiary, no problem. But after treatment with chromic oxide, this is giving the test mean which is the alcohol group remaining there after treatment. You should know it is a tertiary alcohol group. It is this alcohol group that is responsible for red color on treatment with steric ammonium nitrate. Phenol will not answer the test. So you can take it like this. How do you distinguish between phenols and alcohol? Just by treatment with steric ammonium nitrate. The one giving red color will be alcohol. The other one will not give a similar color. So what can be the answer? The possibility will be B only. Question is, presence of which of these OH group responsible for the red color? Presence of B only. B is this one, tertiary alcohol group. So the question requires the knowledge of a test called steric ammonium nitrate. Yes. Next question will be, compound A in the following reaction is, it's a reaction where Grignard reagent appears. There is reductive ozonolysis, and of course treatment with constant sulfate. In this particular question, this is referring to Cannizzaro reaction. It's a combination of several reactions in organic chemistry. And this last one is actually something related to aldol condensation. So here is a question which requires the knowledge of all types of reactions in organic chemistry. So you start with A. What can be A is the question. In this case, the final compound is given. But anyway, there are several methods for attempting the problem, but easy, I think it will be the trial and error method. See whether the first compound satisfies this condition. And when you do that problem, immediately you will be getting the idea which is the correct compound. So to start with one compound, let us take C6H5, C6H5CH2 followed by COCS3, COCS3. This compound on treatment with Grignard reagent, the standard reaction, Grignard reagent followed by hydrolysis, one after the other, will lead to, you have studied ketones on treatment with the Grignard reagent, and the product on hydrolysis will give a tertiary alcohol. Formaldehyde Grignard reagent leads to primary alcohol. Any other aldehyde other than formaldehyde will give secondary alcohol, and ketone will give tertiary alcohol. And this leads to a tertiary alcohol, C6H5CH2. This becomes tertiary alcohol. Let us have OH there, and there is a CH3, already present, and this CH3 will be the additional CH3 coming over there. Kirkinol reaction gives you a tertiary alcohol. So after this step, you are getting a product B, and B will be this compound. And next, there is something like concentrated sulfuric acid heating. Naturally, this will be dehydrated. Sulfuric acid dehydrates this compound. OH from here and this adjacent hydrogen. So that will give you C6H5, CH double bond C, CH3, CH3. You are getting an alkene suitable for ozonolysis. So this compound subjected to ozonolysis is B. This is the compound B. Now ozonolysis is reductive ozonolysis. So what can be C and D? Reductive ozonolysis requires cleavage of the double bond and followed by the formation of this part becomes C6H5CHO benzaldehyde, and the other part becomes propanone CH3CO CH3. CH3CO CH3. So that explains ozonolysis what also. And there are two compounds C and D given. One of this will be C, other will be D. Okay. Now C undergoes Cannizzaro reaction. It is in Cannizzaro reaction that potassium salt benzoate is formed. So naturally, and also you are getting benzyl alcohol. So what can be C? C is the one that gives Cannizzaro. So this will be C, and this will be D. See whether D will undergo this type of reaction. Definitely. This is a carbonyl compound containing alpha hydrogen. When treated with barium hydroxide or alkali, it will undergo mutual aldol addition. And aldol addition will give CH3, CO. One of them will provide carbanion, and that finally gives you CH3CO, CH2, C, OH, CH3, CH3. COH, because one molecule acts as the provider of carbanion, other molecule acts as the carbanion. So one ketone provides carbanion, and the carbanion adds to the other carbonyl compound, make it up. So this is what is called aldol, beta keto. And on heating, it will undergo elimination of water, OH and H, alpha, beta, and so. So you get CH3, CO, CH, double bond CH3 twice. But actually, it is this compound CH3 twice, CH, etc. So all these reactions are satisfied by the compound A. So when you attempt this question, trial and error method gives you the idea about all the reactions. And if one of these conditions is not satisfied, you can go to the next one. That way, the answer for this question is 1. No question and no reaction that is not given in NCERT. All are there, but this is suitable combination. That's all. Answer is 1. Now we move on to next question, number 6. A question from complex chemistry, coordination complexes. The d electron configuration of ruthenium, ethane 1,2-diamine complex, and iron aqua complex. Iron and ruthenium belong to the same group, but just for a variety they have given 2 complexes, that's all. Electronic configuration you are right. First of all, find the oxidation state of the metal, which of course is +2 in iron. Here also it is +2. So you have 2 cation with the number, oxidation number, ruthenium +2 and iron also +2. Iron 26, element number 26. And this will be 26 plus 18 because they belong to the same group, iron, ruthenium, osmium. So plus 18 will give you the atomic number, but that is not necessary because iron has a electronic configuration 3d6,4s2, iron metal, not ion. This is iron. Similarly, ruthenium should have the configuration next to quantum number 4d6, 5s2. So after removing 2 electron, it becomes 4d6, 5s0, and this will be 3d6, 4s0. So in both cases, you have got 6 electron. You have got 6 electron in d orbital. How do they get accommodated? The levels are T2G and EG. You know, T2G and EG will be arranged like this. Here also T2G and EG. But remember, water is a weak ligand and ethane 1,2-diamine is a strong ligand. So naturally, this delta O for ruthenium will be very high and this will be very low. So it will be comparatively very low. So what will happen when you arrange 6 electrons? The electrons will be completely accommodating this level as far as possible. So all the 6 electrons you can accommodate here, 3 into 2. But in this case, 1, 1, 1, 1, 1, so only 5, then comes over here. Because here delta O is small. Compared to pairing energy, delta O is small means electron will be going over the EG level. So it means iron will have T2G4 and EG2, whereas this will have T2G6, EG0. See the answer. T2G6, EG0 for ruthenium, T2G4, EG2 for iron. So answer 2. That's all. Next question number 7. Decreasing order of reactivity of the following compound towards nucleophilic substitution. You know, this compound is benzyl. In benzyl, easily that will undergo. Benzyl easily undergoes SN1 reaction because of the stability of the carbocation. But what they have asked is the reactivity of the following compound towards nucleophilic substitution SN2. That's the problem. What we require is SN2 probability. So you take like this. You want which is the most probable reactant that will undergo SN1 mechanism. The maximum stable, the most stable carbocation will be formed by which of these? Benzyl carbocation is stable, that you know. But when nitro groups are attached to benzene ring, due to the electron withdrawing effect of the nitro, benzyl carbocation will be relatively unstable. So out of the 4 carbocation possible, here there are nitro group, no nitro group. Most stable carbocation is benzyl carbocation, that is 1. Most stable carbocation. And which is the least stable? How do you know that? See, compare the nitro group. Meta is here, meta is here, meta is also there. So in all structure, meta is there. So why do you worry about the second nitro group? You leave it. Now we have got presence of nitro group at ortho in this case, meta in this case, and para in this case. When we attach the group, ortho, meta and para group, the group placed at the meta position will be least effective. When you have substituent at the ortho and para position, they will supply electron most effectively and withdraw electron most effectively. Relatively, meta is not having that much effect. So the presence of nitro at the meta position will not destabilize this carbocation to the same extent as a nitro at the ortho and para. So next stable will be this one. This is marked 4. This will be 4. It will be 4. Now out of the ortho and para, which will be least stable? How do you know that? A group at the ortho position normally will have less effect compared to para. That is in substitution and electrophilic substitution. But in deactivation, nitro group will affect. It will be deactivating this or destabilizing this carbocation both by minus I effect and by minus M effect. Minus M is the same for para and ortho, but minus I will be more for this. That means the least stable will be this one. Presence of nitro at the ortho will destabilize the carbocation both by minus M effect and minus I effect. So least stable carbocation will be this one. So after this, most stable carbocation, this one. Then next will be 4. Out of ortho and para, effect will be more for this and less for this. So the order will be, this will be 3 and the other will be the. So this is the case of stability of the carbocation. Most stable 1. Then comes 3. This one, 4. And then comes 3. So you have most stable carbocation 1, followed by the presence of nitro at the meta, that is 4. Then out of ortho and para, ortho will destabilize more mean, relatively this will be better. So 3 followed by this one will be 2. So this is the order of decrease in stability of carbocation. So that way you will look at it, what will be your answer? They will have maximum, most stable carbocation means maximum tendency for SN1 reaction. So least tendency for SN2 reaction. So if you go this way, maximum tendency for SN1 here and least one here. But for SN2, the opposite will be there. So order of SN2 will be 2 greater than 3. Then you have got 4 and 1. That way the answer will be 1. The higher the tendency for SN1, lesser will be the tendency for S2. So this is the way you find. Most stable carbocation, you arrange the carbocation in the decreasing order of stability. So that is the order in which SN1 reaction will occur. Reverse will be the order in which SN2 will occur. So the answer for here will be here. See, remember, minus M effect and minus I effect should be considered when a deactivation of benzene ring is considered. Minus I and minus M both. Minus M is therefore para and ortho both. But minus I will be more effectively working here, not here. That is the answer 1. Question number 8. Match the following. Say question from the last chapter, second year. Some medicines are given. You have to arrange them. You know what it is? Ranitidine. This is a medicine which is used as a antacid. Then Nardil is a antidepressant. That way, all are familiar to you. So the answer is 3. That's all what is required. Because there is no explanation required. All is given as such in NCERT. So answer is 3. That's all. Then comes question number 9. It's a question from electrochemistry. It is actually a titration between acid and base using EMF method. You studied it properly. When you add base from, suppose this is an acid solution, hydrochloric acid solution, and you are adding NaOH from the burette. After each addition, you measure the pH of the solution. pH will gradually increase. You start with acid mean pH is less initially. Gradually increase and it will be reaching the pH of the NaOH added toward the completion of the titration. But the important point in such a titration is the rate of change of pH at each addition is not the same. Initially, pH changes only through slight amount because the pH actually depends on logarithm of the concentration of H+. Rate of change of pH is maximum exactly at the end point. Rate of change is maximum at the end point, and end point for the titration is pH equal to 7 because both are strong acid and strong base titration. End point will be corresponding to pH equal to 7. So at pH equal to 7, there should be maximum rate of change of pH, and rate of change of pH is the slope of the line. Maximum slope should be there at pH equal to 7, and that corresponds here. You see pH equal to 7, it is here that you have got the maximum change in pH. That point is actually called point of inflection. The straight line will not be obtained. Here the pH is 7 toward the end. It is not the maximum rate of change. The point is maximum rate of change of pH is observed exactly at the end point pH equal to 7. So the answer is 3. That point is called point of inflection of the line. Here at that point actually slope will be infinity. Then Question 10, which will give a anionic missile. For missile to occur, there should be a molecule having hydrophobic part, long chain hydrocarbon part, and a polar part. That condition is satisfied by 2. This one is similar to soap structure, hydrocarbon part, long chain, and this is ionic. So the answer should be 2. Actually, it is a cationic part just neutralizes this. That's all. This will form a anionic missile. This is simply a salt, nothing else. The salt simply dissolving water. 3. Liquid diethyl ether to aqueous NaCl mean no reaction. Sodium chloride will not have any action on either. So nothing, just a choice, that's all. Sodium stearate in pure toluene, nothing will happen. Sodium stearate is soap. You know, soap will not dissolve in toluene. Solubility is negligible. Better, soap will dissolve more in alcohol, not in benzene. In water also it will dissolve, in alcohol also it will dissolve, but in hydrocarbon like toluene or benzene, it will not dissolve. So here is only a completion of the choice, that's all. The relevant answer is this one. Hydrocarbon part, long one, giving an ending, terminating with a negative part. So polar part is here, hydrophobic part is there, condition for missile. Next question, consider hypothetical situation, say theoretical question. In atomic structure, you know already, when n equal to 1, normally L will be 0 only. But hypothetically, what is taken is, if n equal to 1, L can be 0, 1 up to n plus 1 means, for this case of n equal to 1, in this problem, it is given L can be 0, 1 or 2, n plus 1, 1 plus 1, 2. There are 3 subsidiary quantum numbers. Let us call them n equal to 1, L equal to 0, call it 1s. N equal to 1, L equal to 1, call it 1p. And n equal to 1, L equal to 2, 1d. So it is a hypothetical atom. Quantum number slightly changed. It's only a question based upon comprehension. You should know what it is. That's all. If you arrange electron according to this, no other conditions are given mean you can take the m value as such. So this can accommodate 2 electron because there is only 1 s orbital. This can accommodate maximum 6 electron. We can totally accommodate this one, and D can accommodate 10 electron. Now what is the correct statement given? 6 have, when n equal to 6, such an atom will have a 2p valence shell. That is what is given. No, because 6 electron can be easily accommodated in first and second level. The configuration will be 1s2, 1p4, that's all. No need of n equal to 2 level. So 1 is wrong. 6 does not have a 2p level. 8 is the first noble gas, never. The first noble gas can be obtained only when first period is completed and the next period starts. First period will be completed only when this much electrons are accommodated. 2 plus 6, 8 plus 10, 18 electrons. When 18 electrons are completed, first period will over. So the 19th electron will be the inert gas element. 19th electron will go. Yeah, so 9 will not be alkali metal. 19 will be the alkali metal. 8 will not be the noble gas. 18 will be the noble gas. So that way all element positions will be changing. So 1, 2, 3 wrong. What about the last one? 13 electron. Try to accommodate. 13 electron to be accommodated like 1s2, then 2p, accommodate 6. So total 8 electron over. Then you got 5 more. So it will be 1d5. 1d10 by 2. So it is half filled. So 13 has half filled valence subshell. Correct? This is half filled subshell. A question based upon the fundamental principle. That's all. There is no question is it possible or not. The only thing, if such a condition is given, can you apply the principles of the atomic structure? That's all. Now question. So answer is 4. Answer for the question is 4. That is the correct statement. Next question from kinetics. Very simple. You know the method of defining rate of reactions. Instantaneous rate of this reaction written in the expression will be Instantaneous rate in terms of A will be minus 1 by 2 dA by dt. But instantaneous rate in terms of B will be minus 1 by 3 dB by dt. But in terms of the third one, C, it will be minus 1 by 3 by 2, mean minus 2 by 3, 1 by 3 by 2, that is 2 by 3 dC by dt. But you know, whatever be your method expressing the instantaneous rate, all are the same. Rate expressed in terms of A is the same as rate expressed in terms of B in terms of C. That means you can equate them. So the relation you have obtained minus cancels and you get 1 by 2 dA by dt equal to 1 by 3 dB by dt. So dA by dt, what will be then? dA, see whether 1 is correct or not. dA by dt will be equal to dA by dt equal to 2 will be coming over there, minus cancels 2 by 3 dB by dt. That should be equal to 2 into 2, 4 by 3 dC by dt. So which is correct? dA by dt equal to 2 by 3 dB by dt equal to 4 by 3 dC by dt. So answer is 4, based upon fundamental definition of instantaneous rate of the reaction, nothing else. Next will be incorrect statement regarding manganate and permanganate. You know, manganate is MnO4 2 minus. Manganate. Permanganate is MnO4 minus. And in permanganate, Mn plus 7 state. Actually, it has got oxidation number 7 means no d electron. But permanganate, this one has manganese in plus 6 state. There is 1 d electron. You know, manganese is 25th element. Manganese 25th element. So it is 3d5, 4s2. This element. And in this oxidation state 6, all the electrons are gone in permanganate. All the 6 electrons are gone here, all the 7 electrons are gone here. Without electron, permanganate cannot be paramagnetic. So the wrong statement is permanganate is diamagnetic, manganate alone is paramagnetic. So both manganate and permanganate are paramagnetic, wrong. So this is wrong statement. Required is wrong statement. So the answer is 1. Yes. The remaining are correct statement. Next will be incorrect order of reactivity of the following compound in nucleophilic addition reaction, NCERT-based. You know, aldehydes are more reactive than ketone. Sterically hindered aldehydes are less reactive compared to less sterically hindered, that way. So the answer will be, by direct examination will give you the answer. What are the compound given? Propanol, benzaldehyde, both are aldehydes. So most active should be propanol, then should benzaldehyde be coming. Propanone and butanone. Propanone is less sterically hindered than butanone. So what you require is the increasing order, mean least reactive should be coming first. Least reactive should be coming first, mean butanone first. Less than propanone. So ketones are less than aldehyde. 1, 2. Then comes benzaldehyde and propanol. So the answer is 2. No other principles. 60. Next question 15. Among the statement 1 to 4, the correct ones are: periodic table. Beryllium has smaller atomic radius, correct. Beryllium has higher ionization energy than aluminum, correct. But charge to size ratio is not the same. Beryllium 2 positive charges, size is small. But aluminum 3 positive charge and size is also less. So charge to radius ratio of beryllium is actually not greater. Actually, it is less than that of aluminum. So 1 and 2 are correct. What about the last one? Beryllium, aluminum can form mainly covalent compound, correct. So 1, 2 and 4 correct mean 1, 2, 4 correct. Where is it? 1, 2 and 4. So answer is 2. 1 correct, 2 correct, 4 correct. The other is wrong. Correct statement 2. 2 is the answer, right. strength of 5 points is volume, hydrogen peroxide. Then I think you have studied a relation. 100 volume, hydrogen peroxide is equal to, it is actually 30.4%. It is the same as 8.9 molar. And for IAT, you can take double this number, 17.8 normal. So this relation will be helping you to work out any problem of this type. It is 5 points is volume. What is its percentage? So what will you do? 5 points is you write here. Percentage you don't know. So you put X here. Ratio you can equate 100 by 5.6 equal to 30.4 divided by X. So X equal to 30.4 into 5.6 divided by 100. That will be around 1.7. Now the next part is molarity. So consider what all things, this one and this one. 100 volume equal to 8.9 molar. So 5 points is volume equal to X molar. 5.6 divided by 100 equal to X divided by 8.9. That will give you X value. X will be 0.5. So that way answer will be 4. Study this relation by heart. 100 volume, 30.4%, 8.9 molar and 17.8 normal. Next 17 question. Consider the following molecules and statement related to them. They have got orthohydroxybenzoic acid and parahydroxybenzoic acid. Very simple question it is. Orthohydroxy will have intramolecular hydrogen bonding. Para will have intermolecular hydrogen bonding. So naturally, effectively, this will have intermolecular hydrogen bonding will be this B. B is more likely to be crystalline than A. Because the higher the molecular weight, is easier will be for crystallization. So A, the statement A is correct. B has higher boiling point, correct. Associated molecule will have higher boiling point. So A and B are correct. B dissolved more readily is wrong. Because the higher the polymeric nature, solubility will be less. That way C is wrong. So correct answer will be A and B only. A and B mean answer 3. Not a difficult question. Next one, 80. Complex A has a composition H12O6Cl3Cr. Actually, H12O6 is 6 molecules of water. Cl3 will be, as usual, the counter ion. So you can represent the compound in several ways. Question is, which one is the correct answer? The only clue given is, on heating, this molecule loses 13.5% of the original mass. So convert this into molecular term. Suppose the total you are taking 100 gram. 100 gram you are taking. Then it will losing 13.5 gram. 13.5 gram. It will be losing as water. So if you take 1 mole of the complex, how much it will use? Suppose it is losing 18 gram water, that means there is 1 molecule of water. If it is losing 30 gram water, that means it will be having, this is 13.5. For every 100 gram complex, 13.5 gram water is lost. So if 18 grams of water are lost from 1 molecule, it means there is 1 H2O outside. If 36 grams of water are lost, it means there are 2 molecules outside, and so on. So the point is, you consider 1 mole of the complex, add up all these numbers. Chromium 52, chlorine, etc. You know, when you add up, the molar mass of the compound can be obtained as 266. When you add up, you get 266. 266, you are heating. How much water is lost? 13.5%. So 266 times 13.5 divided by 100. This will be working out to 36. So 1 mole of the complex will lose 30 gram water, means 2 molecules of water will be lost. 2 molecules of water will be lost only from the second compound. The principle is, any water remaining as coordinated water inside the complex part will not be lost on simple heating. It is actually treatment sulfuric acid. Very strong heating will result in loss of this one, but sulfuric acid cannot actually take out all this water. So on treatment with sulfuric acid, only this water crystallization will be lost. So the account given is 1 mole loses 2 moles of water, mean it is satisfied only by the second formula. This water cannot be removed by sulfuric acid. Formula is 2, answer is 2. A mixture of 1 mole each of hydrogen, helium and oxygen. 1 mole each of hydrogen, oxygen, helium. This is 1 mole hydrogen, 1 mole helium, 1 mole oxygen in a cylinder. But what is given is partial pressure of hydrogen is 2. This hydrogen has got 2 partial pressure, 2 atmosphere. Volume is the same, pressure, total pressure, all these are subject to the same, it is present in the same vessel at the same temperature and so on. So if 1 mole hydrogen can exert a partial pressure of 2 atmosphere, naturally 1 mole helium also will exert a total of 2 atmosphere. 1 mole oxygen also can have 2 atmosphere. Partial pressure is the pressure exerted by one component in a mixture. If 1 mole hydrogen can exert 2 atmosphere, naturally others can also exert independently 2 atmosphere each. So total pressure in the mixture will be 6 atmosphere. No more calculation. 6 atmosphere, answer 4. Next question. It's a question, actually there is no answer there. Probably there is a mistake. As such, there is no reaction between an alkyl. Suppose you have a reaction of the type CS3I plus an alcohol ROS. No reaction there actually. So there should be something wrong. It may be, this may be potassium part, tertiary butoxide. Only then you will have a correct acceptable answer. Otherwise, there is no answer. No reaction. That will be the answer. Alkyl added does not have a reaction in alcohol. Of course, it is an ester. Treating one ester with another alcohol may result in trans hydrolysis. But such a thing will not never happen in alcohols. No reaction. So probably this may be corrected to this. Then only the answer given, what they have given is this answer. There also there is something wrong. Anyway, suppose this is one. This is a nucleophile, tertiary butoxide nucleophile having high bulk. So it is not easy for this tertiary butoxide anion to attack hydrogen at this junction or at this junction or at this junction. There is a compound given with this formula. This is I and this is CS3. The especially bulky nucleophile cannot attack this hydrogen. If it can attack this hydrogen, possibility will be it attacks this hydrogen. The possibility will be this one abstract this hydrogen, electrons are brought over there and iodide is the leaving group. So double bond here. But actually it cannot because there is a steric hindrance. It cannot attack this also. Even if it is attacked, nothing will happen because the iodine should be at the beta position. So that is not possible. So if this is there, the most probable answer will be, see there are 3 hydrogen atoms there. This is CS3. With this bulk, it can attack butoxide anion can attack this one. So it attacks the hydrogen. Hydrogen comes, electrons are shifted like this and iodide leaves. So the expected product will be this one. This will be iodide gone, mean this is the product expected. And that product is given here. That means even if it is butoxide, the best answer will be 1. So that requires some correction in that question. As such, there is no answer. I give this answer only to show that there is a possibility for a question. But even in this case, remember, butoxide bulky anion cannot actually attack this one, causing a double bond there. There is no carbocation shifting also, because carbocation is not formed here. If carbocation is involved here, This can be the answer. A carbocation rearrangement is possible, but it's not at all possible. It is possible only when this is leaving, say, suppose a tertiary atom. Hydrogen will be gone and you get a carbocation. Rearrangement can result. But that is not normally occurring in this case also. So, possible answer will be 1. Assuming this is the reactant given. Then 6.023 10 raised to 22 molecules are present in 10 gram of a substance. So, what is the molecular weight? 6.023 10 raised to 23 molecule constitute 1 mole mean molecular weight will be 10 times that given number. So, directly first sentence gives you molecular weight equal to 100. 1/10 mole weigh 10 gram. So, 1 mole will weigh 100 gram. Now, 10 gram of a substance, that means molar mass is there. The molarity of a solution containing 5 grams of the substance X. Molarity of a substance solution containing 5 gram. So, how many moles are there? 5 gram present in how much? 2 liter. 5 gram present in 2 liter. So, 5/2 gram present in 1 liter. Now, make it mole. 5/2 gram, make it a mole mean divided by 100. 5 gram in 2 liter. So, 5/2 gram in 1 liter. Make it mole by dividing by this one. So, the answer will be 25. This is the answer, because that should be expressed in terms of 10 raised to minus 3. This should be expressed in terms of 10 raised to minus 3 mean it will be 25 into 10 raised to minus 3. Otherwise, the answer will be 0.025. That is 20. The answer as such is 25 because there is a 10 raised to minus 3. 22. 250 milliliter of an aqueous solution containing 0.73 gram protein A isotonic with another solution. For isotonic solution, the condition will be the molar concentration should be the same, effective molar concentration should be the same, because proteins are given, no case of association or dissociation. So, just compare the number of mole per liter. Take the first case, 250 milliliter contain 0.73 gram mean 0.73 into 4 grams are present per liter. And let the molecular weight of this will be MA. It is protein A. So, let us write it MA. This many gram per liter divided by MA number of mole. But that should be the same as number of moles of the other. Other case it is 1.65 gram in how much? Aqueous solution containing. It is actually, this is with 250 ml of this solution. So, we are compensated by multiplying 4. Second case, 1 liter of another aqueous solution. So, this is actually present in 1 liter. And the molecular weight will be MB. Let it be MB. Temperature same. So, what is the ratio or the molar masses of A and B? What you require is MA by MB will be equal to, bring this MA here, bring this here, 0.73 into 4 divided by 1.65. And the result should be expressed in terms of 10 raised to minus 2 mean. Actually, this will be working out to 1.77, but because there is 10 raised to minus 2 there, it is actually 177. The answer will be 177. That is question 21. Now 23. Volume of ml of 0.1 normal NaOH. Very silly question. Because in terms of normality, when the reaction takes place, relation is V1N1 equal to V2N2. Volume of one solution in the normality should be equal to volume of second solution in the normality. So, first case, we have got 0.1 normal NaOH. Let this be NaOH. This is the volume to be calculated, but the normality is 0.1. The second solution volume actually 10 ml and normality is 0.1. So naturally V1 should be 10 ml. The answer is 10. Nothing else. V1 in 1 equal to V2 in 2. Answer is 10. Next question. Number of CO group present in a tripeptide, aspartic acid, glutamic acid, lysine. You should know the nature of the acid. Aspartic acid is a acidic amino acid. And acidic, all amino acid will contain one NH2 and one COOH. But acidic amino acid will contain more than one. Aspartic acid actually contain 2 COOH groups and 1 amino group. Glutamic acid also contains 2 COOH groups. But lysine basic amino acid contains only 1 COOH group. And question is, in the tripeptide form, how many CO will be remaining? After the formation of the peptide bond, CO will remain as such. So the answer will be 5. Very simple question. The only thing to be how many COOH groups are present in aspartic acid and glutamic acid, nothing else. Answer is 5. Now the last question. Acidic solution of dichromate is electrolyzed for 8 minutes using 2 ampere current. So how many Faradays are passed? That is the first thing to be calculated. It is 8 minutes and 2 ampere current means the quantity of electricity will be 8 into 60 seconds multiplied by 2 ampere. So 960. 960 coulombs are passed. A convenient number because Faraday is given as 90,500. So how many Faradays will be this one? F equal to 960 divided by 90,500. 600. They are given the 90,000. Oh, easy. So cancellation will give 0.01 Faraday. Easily you get the answer 0.1 Faraday. But see the change taking place. Dichromate Cr2O7 2- has chromium in +6 state. Each chromium here is in +6 state. But in the final product is Cr3+. So you have to add 3 electrons per mole of chromium. If you want to produce 1 chromium, you have to add 3 moles, 3 electrons. That means for getting 1 mole chromium, you require 3 Faraday. Addition of each electron represents 1 Faraday. So 3 electrons to be added means 3 Faraday should be added. 3 Faraday can produce 1 mole chromium. So 1 Faraday can produce only 1/3 mole. So 0.1 Faraday can produce 0.1/3 and 0.1 can produce 0.01 divided by 3 mole chromium. You see the chromium produced. And this chromium in terms of mass will be 0.01 divided by 3 into atomic mass is 52, that is given. Atomic mass is given 52, so into 52. This will be around 5.2/3. 5.2 divided by 3, just slightly less than 1.8. Will be 1.77 or so. But actual mass obtained is, this is theoretical amount to be obtained. But how much is actually obtained? You are getting only, you are passing this one, how many? 0.104 grams obtained. Actually you get only 0.10 gram. Theoretically you should get this much. That means efficiency will be, this is something wrong. This is 0.01/3. So this is actually 0.52/3. This will be 0.177. Just correction, that's all. It is 0.11. So the efficiency should be actual amount obtained by theoretical amount to be obtained 177 into 100. It will be around 60%. It will be coming out to 0.6. So in terms of percentage, it will be 60. That way you calculate it. Problems are very simple. The principle you should know. That's all. Okay. That's all. Thank you.